everyone, we're going to expand each expression using the binomial theorem. These are kind of the easy ones. Also, both of these have ones in them, so I'm going to treat them a little different than I would the next two here. And what you want to do is when you start this is we have the first one is x plus 1, to the fifth. I'm going to write that as a 1 to the fifth. Plus 1. Okay, there's my 1. So the way you want to write this is, like we did with the Pascal's triangle, 5, 0. And this is going to be x to the fifth. Since this is a 1, we don't really need to put the 1 in here because that's just going to, especially since it's positive. Plus 5, 1. And we go down 1, x to the fourth, plus 5, 2, x to the third, we're going down, plus 5, 3, x to the second, plus 5, 4, x to the first, plus 5, 5, x to the 0. Now, what we need to know on these is, if you watched my other videos, we know that this equals 1 and this equals 1. Also, anything to the 0 equals 1. We also should know that this one equals 5, because that's in 1, and that equals your n. So this is 5, and also this one's 5. Okay, these two are the same. This is 5 factorial over 2 factorial times 3 factorial, which is actually 5 times 4 times 3 factorial over 2 times 3 factorial, or 2 factorial is just 2. So this is going to be 10. This one's also going to be 10 because all you do is switch these two. And so you have 10 here. So your answer is going to be x to the fifth plus 5x to the fourth plus 10x cubed plus 10x squared plus 5x plus 1. Because that's 1 and that's 1. 1 times 1. And again, like I said, I'm treating the ones a little differently because they're kind of easy. And let's do the next one. We have x minus 1 to the fifth. Now in this case, we have 5, 0, x to the fifth times negative 1 to the 0 plus 5, 1, x to the fourth, negative 1 to the first, plus 5, 2, x cubed, negative 1 squared, plus 5, 3, x to the second, negative 1 cubed, plus 5, 4, x 1, negative 1 to the fourth, plus 5, 5, x to the 0, negative 1 to the fifth. So this would be your A and your B. Now, we know that this is 1, this is 1. Also, this is 5, and this is 5. We also know from our previous one we did this is 10, and this is 10. So basically, anything to the 0 power is 1. We'll cross those out, and we can proceed. We have x to the fifth plus, now, negative 1 to the first power is negative 1. So basically what we have is minus x to the fourth. Then we're going to have plus 10x cubed, because this is going to be positive 1. This is going to be negative 1, positive 1, negative 1. So basically The next one's going to be negative. So we have negative 10x squared plus 5x minus 1. And that's your expansion. Alright, so those are the ones with the ones. Now, the other ones come out a little better. I'm going to explain these in more detail. So we have x minus 2 to the 6th. So basically, we're going to write this as 6, 0, which we know is 1, x, and then we have negative 2. Now, I'm just going to keep writing x and negative 2 here, and then I'm going to put the powers up here in a minute. Okay, plus 6, 1, and I'm going to put x, negative 2, plus 6, 2, x, negative 2. Again, this is your a, and plus your negative b part that we're doing. Plus 6, 3, x, negative 2, plus 6, 4, x, negative 2, plus 6, 5, x, negative 2, plus 6, 6, x, negative 2. Now, what you're going to do is start with 6, 0, and then you're going to go 5, 1. So your A part's going down and your B part's going up. And this is going to be 4, 2, 3, 3, 2, 4, 1, 5, 0, 6. Okay? And what I want to also do is show you what this is. This is really 6 factorial over 0 factorial times 6 factorial. And what I like to do is change these. So instead of using n factorial over j it's not even over. Okay, so n factorial, and then we have over j factorial times n minus j factorial. This is hard to do the periods. Okay, I change this to n factorial, and I put the n minus j factorial, and then I do the j factorial. So what I'm going to do is rearrange this. So when I do the first one, I'm going to do 6 factorial over 6 factorial, then 0 factorial. Then I have these matching. So if you notice, this 6 matches here, and this 0 matches here. Okay? Plus, this is going to be 6 factorial, and then I'm going to write 5 factorial times 1 factorial. And this would be x to the 5th, negative 2 to the 1st, and so forth. So that these, oh, this is a 1. So that these numbers match the order that we're writing them in. So I just rewrite the formula there. Now, we know that this equals 1, this equals 1. We should know this equals 6 from our formulas, and this one equals 6. And you can either use your formula here or Pascal's triangle, and what we're going to get on this is x to the 6th plus, because this equals 1, anything to the 0 is 1, so we x to the 6th plus 6x to the 5th times negative 2 plus 15x, this equals 15. Let me do this in different colors. It's 15. So 15x to the 4th, negative 2 squared. Then we're going to have plus 20x cubed negative 2 cubed plus we get 20, then we're back down to 15x squared negative 2 to the fourth plus so 15, where are we at? 15 plus 6x negative 2 to the fifth plus negative 2 to the sixth. Now in the next slide I'm going to go ahead and multiply these coefficients. So this right here is 4. This is negative 8. This is 16. This is negative 32. And this is 64. And I'm going to multiply all this together, and you're going to get x to the sixth minus 12x to the fifth plus 60x to the fourth minus 160x cubed plus 240x squared minus 192x plus 64. Alright, on the last one we have x plus 3 to the fifth. Now, what we're going to write is 50 x to the fifth 3 to the 0 plus 1 x to the fourth 3 to the first. You see how we're going down? Plus 2 x cubed 3 squared plus 3 x squared 3 cubed plus 4 x to the first 3 to the fourth plus 5 x to the 0 3 to the fifth. Alright, and now I'm going to go ahead on this one and write all this out. I'm going to write this as 5 factorial, and I'm going to write the 5 factorial here, 0 factorial, x to the fifth times 3 to the 0. Next one's going to be 5 factorial, and this is going to be 4 factorial times 1 factorial, x to the fourth, 3 to the first, plus 5 factorial, and then we're going to have 3 factorial times 2 factorial, x cubed 3 squared. The next one's going to be 5 factorial plus 5 factorial, and we're going to have 2 factorial, 3 factorial, x squared 3 to the fourth plus 5 factorial or 1 factorial times 4 factorial, and this is going to be x times 3 to the fifth plus 5 factorial over 0 factorial times 5 factorial, x to the 0, 3 to the sixth. So let's look and see what we have. We already know that this equals 1. This equals 1. We also know that this equals 5. This equals 5. And we also know that this equals 6 from the previous one we did. And this is 6. So now, and this is 1. And anything to the 0 is 1. So now all we have to do is multiply, for example, 3 times 5. We're going to be multiplying 3 times 5 is 15. We're going to be multiplying 9 times 6, which is 54. Then this is 81 times 6. And then I think this is 243 times 5, and so forth. So what we're going to get is x to the fifth plus 15x to the fourth plus 90x cubed plus 270x squared plus 405x plus 243. And that's your expansion. We have 1, 2, 3, 4, 5, 6 terms when we had x plus 3 to the 5th. And that's all. The next set we're going to have has more coefficients involved, so they get more complicated. Thank you and have a nice day. Bye-bye.